Namaskar. Physics is life. Physics is fun. And the journey from real life experiences to the joy of nature is physics. From nucleus to the size of the universe. From ants to antennas. From quarks to quasars. From the harmony of heartbeats to the music of the universe. From the darkness to the colors and even beyond the colors. Everything is physics. The study of physics means trying to find out what the universe is made up of and how these things move, how these things interact with each other. This is our first lecture in class 9th, and in class 9th our chapter is motion. So first of all, let us find out what is motion. In physics, we can state the two states of matter and the bodies. The first one is the state of rest. Now, which body can be called as at the state of rest? The body which doesn't change its position. The body which doesn't change its position with respect to time is called as the body at rest. Here, an important term is there. The body should not change the position. It should be there only wherever it was. In the given time span, suppose we are observing this board. At the given instant, it is located, it is situated at this position. And next, suppose after half an hour, or 1 hour, or 1.5 hours, if the board is observed, it is going to remain here. Can we call it as the body at rest? The books lying in the shelves, the things which are placed on the table, our building, are these all at rest? If yes, then let us find out the state of rest and state of motion in detail. State of rest can be defined as when a body do not change its position with respect to time, then it is said to be at rest. Now here, two terms are important. Position and time. If I am having this duster, which is an object, a body, and at time 8:10 a.m., if this is its position, then after certain time, 8:20 a.m. say, in the 10 minutes, if the duster is remaining here, then it will be said to be at rest. But suppose during this time, if it moves, if it changes its position, then what will you call it? Yes, you are right. We will call that the duster is in motion. So, I'll just give you the examples of these two books on the shelf. Objects on the duster, on the table. Wall clock, a park car, a ball held by the bowler, a ball held in hand, a ball held by a bowler. All these objects, they are at the rest. Now let us define the motion. Let us define the state of motion. It will be directly defined as when a body changes its position with respect to time, then it can be said in motion. The ball, if it is released, it is going to change its position. So this is the motion. A moving car, moving train, moving vehicles, moving trucks, and the motion of the moon around the earth, motion of the earth around the sun, a rotating fan, a spinning top. All these, they will come in the state of motion. State of motion can be defined exactly as when the body changes its position. When a body changes its position with respect to time in the given frame of reference, then it is said to be in motion. Here, the change in position is taking place with respect to time, and one new term, a new term is included here called frame of reference. This is important. Now, what exactly does this frame of reference mean? Simple. Suppose an object is there, a building we can consider. A building is there and three persons, observer A, observer B and observer C, are looking to this building. Let this distance is 10 meter. Distance of the building from B is 2 meter. And distance of the building from C is say 8 meter. Now, if I ask A at what position you are with respect to the building, or if I ask A that at what distance the building is from you, what will you say? He will say the building is at 10 meter towards my right hand. Exactly. B will say the building is at 2 meter distance towards my left hand. What about C? C will say the building is 8 meter at a distance of 8 meter above. So the answer is different. For A, it is towards right. For B, it is towards left. And for C, it is above. And thus, we will always need to specify that from where the motion is observed. Let me just give you an example. If you are standing at the platform and train goes towards left, you are standing on the platform and the train is going this side. You will say that the train is moving towards my left hand. But consider another person which is exactly on the opposite platform. What will he say? Yes, he will say that the train is moving towards my right hand. Now there is no difference, no fault of the train. It is just moving from one point to the other. But B is saying that it is moving towards right hand and A is saying towards left. That is why the frame of reference from where you are observing the motion is always important. So, coming back to the part, motion of a body can be, the body is said to be in motion if it is changing its position with respect to time. Example, if I want to give examples, then the first one you can take as a kicked ball, football, it is in motion. A car moving along the road, the rotation of the fan, a fan rotating about its axis, the revolution of the earth around the sun, and many more. We can give the examples of motion, infinite examples of motion. I hope you have understood the concept of state of rest and state of motion. I have explained the frame of reference to you. I have also explained the position and the time. If there is an assignment for you, just try to write down the different examples, 20 examples of the bodies which are at rest and 20 examples of bodies which are in motion. Now let us study the different types of motion. Depending upon the nature of the motion of objects, we can classify the motion basically into three categories. Motion can be classified into three categories. It is called as one-dimensional motion, two-dimensional motion, and three-dimensional motion. I'll write it 3D, three-dimensional motion. To understand the nature of this motion, let us go back to the basic concept of position. Suppose I want to describe the position of point P. Then either I can take it on an axis, or I can use the Cartesian coordinate system. In Cartesian coordinate system, by taking x and y axis, this is x axis, this is y, and this distance will become x. This distance will become x, and this distance will become y. So, in xy plane, I can write the position of this point P as P having coordinate x, y. To describe the position of the object P in three dimensions, we will take the distance of this can be taken as x, and then in three dimensions it can be represented as x, y, and z. These are the coordinates of point P in x, y, and z plane. So, we can consider this position. One-dimensional motion can be explained as if any one of the position coordinates if any one of the position coordinates of an object change with time, then it is said to be one-dimensional motion. In this, either x or y or z, any one of the three position coordinates will change, remaining the other two constants. For example, if this toy scooter, if it is moving in this way, earlier the position of this toy was say x1, and then it had moved to the distance through a distance. This is the distance it has covered, and thus this one distance, if it is covering, then this distance can be taken into consideration. No y is changing, no z is changing, only x coordinates are changing, and that is why we can call it as one-dimensional motion. The free fall of an object, a ball released from a certain height, its y will change. Initially it was at this position and then came down, remaining x constant and z constant. So in this case, only one of the position coordinates of the objects are changing, and hence it is called as one-dimensional motion. Example we can give as a car moving along a straight path, straight road, a rolling ball along floor in straight line. Then we will call it as one-dimensional motion. Then comes the two-dimensional motion. And it is in this, any one of the position coordinates of the object was changing. In this, any two of the position coordinates of the object will change. Remaining the third coordinate keeping constant, it will remain constant, and that's why. Suppose this point P is having x1, y1 and z1 are the position coordinates. And time t, if it is moving to another point, say q, now its coordinates are going to change. q2, x2. For q, we will have x2, y2 and z1. Z will remain constant same. So since z is not changing, only two of the position coordinates are changing. This can be called as two-dimensional motion. Example we can view as crawling of a child if the child is crawling, he will move like this. An insect moving along the floor, etc. Then comes the three-dimensional motion. Three-dimensional motion. In the first case, only one of the position coordinate got changed. In two-dimensional motion, two of the position coordinates got changed. And in three-dimensional motion, all the three position coordinates will get changed. That means x, y and z. Example of this can be given as the first flight of bird. Takeoff or landing of a plane. See, while taking off or landing, the three position coordinates of the plane x, y and z, three of them, all of them will get changed, and that's why we call it as three-dimensional motion. One more example we can cite here as a flying kite. X, y and z. All the three position coordinates will change, and that's why these are the three basic types of motion: one-dimensional motion, two-dimensional motion and three-dimensional motion. In addition to this, we can have other types of motion like rotation, a spinning top, spinning fan, rotating fan. They will come in this category. A bottle cap. A bottle cap, when it is rotated like this, it comes up. If it is rotated like this, it goes down. Definitely, these are different types of motion, and thus this is rotation. Then circular motion is there. When the object covers the path, circular path, in a certain time, then it will be called as circular motion. Then there are periodic motion. Those motion which occur repetitively, like the rising of the sun, the rotation of the earth, the revolution of the earth, the sewing machine needle, it just oscillates like this. A branch of a tree, it oscillates like this. These are the periodic motion. They will have their oscillation, they will have certain time, fixed time, and they will repeat themselves. As periodic motion are there, we can also come across non-periodic motion. Those type of motion which do not repeat their motion periodically. They will come in this category, non-periodic motion. So, this is what the types of motion are there. In our next module, we will see in detail about the terms required for motion like distance, displacement, speed, velocity, and others. By the time, this is VIKRAMSINGH CHAUHAN takes your lead. Thank you.